Okay, so today we're going to learn about basic probability. So it's going to be kind of simple. Later on, we're going to do some interesting, fun activity that we haven't done before. So I hope you guys will enjoy it. Okay, so probability is like basically it's how likely something is to happen. So, for example, it's very likely that tomorrow when my alarm rings at 6 a.m., I won't wake up exactly at 6 a.m. I'll probably wake up at like 6:05.
My bus is at 6 a.m.
Really? That's really early.
I know.
Oh, dang. So it's like the desired outcome over all possible outcomes. It's like a little fraction, but it can be expressed as like percents or fractions, any of that stuff. So let's do a little warm-up. I'm sure a lot of you guys will be able to do this, so I hope a lot of you answer in the chat. Okay. Superhero Sam spins a wheel. If it lands on red, he will defeat an evil dragon that is robbing the bank. But if it lands on blue, he won't be able to defeat the dragon. So what are the chances of Sam defeating the dragon? Type in the chat. So remember, if it lands on red, he will defeat. If it does, and it lands on blue, then he won't be able to defeat. Yeah, so you guys are right. It's 3/4 because, well, like 3/4 of the circle is red, and that is what we want. So the red is our desired outcome, and then everything is just 1. So 3/4 over 1 is just 3/4. Somebody have their hand up? Is that on purpose?
Yes.
Uh-huh.
Why does the dragon need money?
Because it's evil.
It has fire powers. I think he can live with that.
I think he's just trying to create extra chaos. I don't know, maybe you should ask the dragon yourself. So next question, a bag contains 10 marbles. If you randomly draw out one marble, then there is a 50% chance that the marble will be red and a 50% chance the marble will be blue. So how many of the marbles in the bag are red? Okay, so everybody is telling me 5, and you will be correct because, well, 10 marbles, half of it's red, half of it's blue, half of 10 is 5. Pretty simple.
Sorry, my computer crashed.
No, you're good. Okay, so let's see. We're just doing a little like warm up right now, so this should be pretty simple. Oh wait, why is the answer on there? Nobody sees that, right? Totally not.
Is it in present mode?
I don't know why it's there. I think like the animations are just not working or something. Or maybe she forgot to add it. Anyways. Oh, you're in 8th. Okay, 1 second. What's your name? Sanvi? Okay.
1 is not a prime number. Just so you guys know.
How do I do this again? Hold up. Oh wait, no, I know what to do. I go to breakout rooms and then go to your name, move to 8th. Hopefully that works. Okay, yeah, she left. Okay. So anyways, let's see what you guys said. I see like 1/2 and then also 2/3. But no, it's okay. So yeah. So the prime numbers, if you remember, are gonna be 2, 3, and 5. So that's 1/2. Okay, so whenever you do like math counts or something like that, there's some like basic information that you should know. So like they're gonna assume you know these basics, but I don't know about you, I didn't really know that much about like a deck of cards. So whenever these questions came up, I was really confused. So we're gonna go over the basic information. So first, a deck of cards has 52 cards. And this is like without jokers, okay? If you have jokers, then it's gonna become 54. But like a normal standard deck has 52 cards. And then there's 13 of each suit. I think that's how you say it. spades, clubs, diamonds, and hearts. So like, I don't think you would really need to know this, but just so you know, the spade is the one that looks like this, kind of like a curvy triangle. Clubs is like a clover kind of shape. I'm not really good at drawing, guys. A diamond is, well, just like that. A heart is a heart. So yeah, just to keep in mind. And the face cards are jacks, queens, and kings. So these, like on the card, it's gonna have like a person on there, like yay. And it's not gonna have like a normal thing would have like 1, 2, 3 shapes, but this won't have that, and it'll just say like jack or something.
What about the A?
The ace is
Ace.
the ace acts as number 1. So it looks like there's only one of it on there, so this would be like the ace of diamonds, but like it acts as number 1, but we call it an ace. So and then a die, unless it says like otherwise, like it's a special die, it has 6 sides numbered 1, 2, 3, 4, 5, and 6. Okay. And a coin has 2 sides, obviously, tails and heads. And a fair coin has a 50% chance of landing on each side. So sometimes they'll say like, oh, this dude flips a fair coin. And I didn't know what a fair coin was, but it basically means that you have an equal chance of landing on either side. So they haven't messed with it in some way. So my voice sounds weird. But anyways, okay, independent events. So if 2 events are independent, they don't affect each other's probabilities. So example, and I know like this might sound a little lectury, but I promise we're gonna have a really fun event at the end. So let's just get through it, okay? So Biden decides to drink coffee on Monday morning, and then King Charles III decides to drink coffee Tuesday morning. And the 2 events, they didn't affect each other, right? So like Biden didn't drink coffee because he somehow knew King Charles III would drink coffee the next day. So these are 2 unrelated events. And then Shin Lim, who I think is like a magician, he draws a random card out of a deck and tosses a fair coin. And no matter what card he draws, it doesn't affect the outcome of the coin. So like, it doesn't matter if I got like an ace or a jack or something, it's still gonna be like the coin is separate from the deck of cards. So that's why like separate, independent, same thing. Yes, unless it's a coffee conspiracy.
Why do you guys know if they're drinking coffee on Tuesday morning or Monday morning?
We don't, but this is just an example. Oh yeah, actually we are stalking them, Damien knows. So if you want to find the probability that independent event number 1 occurs and independent event number 2 occurs, you multiply the probability. So think independent and multiply. Okay, we're going to see this in action a little bit. So let's see. There's a 50% chance of rain on Sunday and a 30% chance of rain on Saturday. What is the probability that it rains on both days? And make sure to answer as a fraction. So, well, it raining on one day and then it raining on another day. Technically, it's like kind of related. It could be, but like right now we're thinking of it as independent. So, there's a 50% chance the first day and a 30% chance the second day. So what is the probability that it rains on both days? So in other words, what is the probability that it rains on Sunday and on Saturday? Well, since it's and, we multiply. You didn't miss much, we're just doing a little thing. Yes, somebody super smart is telling us in the chat that it has to be a fraction. So yeah, make sure you do that. So 50% is the same thing as 1/2. 30% is the same thing as 3/10, right? So when we multiply, we get 320. Yep, that's like a little prettier thing, I guess. So I'm not sure why you guys got 115 or Yeah, but like 15% is right because 20 times 5 is 100, 3 times 5 is 15, but it's not 1/15. Okay. So when events are independent, you can use the fundamental counting principle, and we learned this a long time ago. So if you came to the class where we taught basic counting, you should know this already. Now, dependent events. So if independent events are separate, well, then dependent events aren't separate, right? They're together. They have some sort of relationship. So if two events are dependent, they do affect each other. So for example, this is like a really common example. So you pull one card out of a deck and well, it's an ace, okay? You pull another card out of the deck without replacement. So this without replacement, you may or may not have heard about this before, but here, without replacement, this is like an important thing to see because without replacement means that after you draw a card, you're not going to put it back in the deck, you're just going to leave it out. So now, if you started with 10 cards, if you don't replace it, now you have 9 cards. So, right in this situation, it's another ace. So these events do affect each other because at first, the probability of an ace is 4 out of 52 because there's 4 aces total. But after that, since one ace is gone and one card in general is gone, it's going to become 3 out of 51. So we have to consider how an event affects another event. So we have to make sure we can like distinctly tell between an independent and a dependent event. Also, if I'm going too fast or if you have any questions at any time, just raise your hand or say something in the chat, okay? So practice. Out of 18 girls and 14 boys, 2 kids are randomly picked to feed the class hamster for a week. What is the probability that both kids picked are girls? And so keep in mind that after one girl is picked, well, she's not going to get picked again, right? So you need 2 different people, which means that this is dependent. So, yeah. So somebody tell me in the chat. Okay. I think that's really close, but there's one little thing that's kind of wrong. So like when you take out a person, it takes them out of the girl pool. Like instead of 18 girls, there's now 17. But then also in total, something happens to the total number. Okay, yeah. So you guys are right because at first it's 18 out of 32. There's 32 total, 18 girls. But after that, one of the girls is basically gone. So instead of 18 girls, now there's 17 girls. And instead of 32 kids, there's 31 kids. Yeah, you don't have to do the multiplication. As long as you got that answer, you're good. Yeah, don't worry about it. So does that make sense to everybody? If anybody has a question at this point, it would be a good time to ask. Or if you understand, say something in the chat. Yeah, thanks, Damien. So that I know who's like paying attention and stuff. Like type 1 if you feel great, 2 if you feel iffy, and 3 if you feel lost. I'm gonna wait until like most kids answer. Okay. -1. Hey, no spamming. And it's okay to not say 1, okay? So be honest. Alrighty. Okay. So, if you feel iffy, do you think you just need more practice with it? Or do you think like I should re-explain it? So somebody tell me.
Re-explain.
Okay, so should I re-explain the dependent only or the independent too? So this problem?
Yeah.
Okay. So let's redo this one. It is a little confusing at first. So, okay, first of all, thanks for asking to explain it again. Okay, so let's see. Let's go a little slower. So there's 18 girls and 14 boys in a class, okay? So in total, how many kids are in the class? Well, in total, there's 18 plus 14 or 32 kids. There's 32 kids in a class. 18 of them are girls, 14 of them are boys. And then out of them, 2 of the kids are randomly picked to feed the class hamster, okay? So we're trying to choose 2 of them. And now we're trying to find the probability that both of the kids, what happened there? That both of the kids are girls. So it could be like they're both girls, one of them's a boy, the other's a girl, or both of them are boys. But we're trying to find the probability where both of the students are girls. So in order to do this, we need to find the probability of picking a girl in like as the first kid, and then the probability of picking a girl again as the second kid. So here, let's have our first person being picked, number 1. Okay, for number 1, remember probability is what we want over total. What we want is the girls, right? Well, there's 18 of them. So 18 is the what we want, and the total, remember we had 32 kids. So this is the probability of picking a girl as the first like person. And then let's move on to our second person. So now we also have to do like desired over total. So we want girls right now, right? But we have to remember that one of the girls was already picked as the first person. So they can't get like, she can't get picked again, right? So now instead of 18 as our possible girl options, we only have 17. And also 32 kids in the beginning, but one of them is like not an option anymore. So now there's only 31 kids total that we can choose from. And since it's like you have to pick the first person as a girl and the second as a girl, it's multiplication. So when you multiply, you get some big number that we don't really need to know. Does that make sense? Everybody say in the chat now how you feel, or you can tell me after our meeting. So -1, hopefully not. Okay. Already. Okay, that's good. Let's move on then. Okay, so second practice problem. You draw a card out of a deck and draw a second card without replacing the first one. So this is without replacement, okay? What is the probability that both are red face cards? So another thing to know is that half of the cards in a deck are black and the other half are red, okay? And well, there's 52 total. So 26 of them are red, 26 of them are black. Okay.
You can like divide 52.
So it's like a fraction. So it'll be like, it's not really like division. If you think about it like that, it might get a little confusing. So instead of thinking of it as dividing, think of it like 1 out of 2 cards are going to be red, like that. So it's not dividing, but this is also the same as 26 of the 52 cards are red. So yes, you could divide by 52, but you could also think of it as just 1/2. Okay. Okay, so let's see. I see some good answers. So first, well, what is the probability that the first card is red? So we're picking 2 cards, right? Well, half the cards are red, so 1/2. Pretty simple. Now the second card. Now there's, instead of 52 cards, there's 51 cards total. Instead of 26 red, there's 25. Whoa, that's a really weird 5. Hold up.
No question.
Mhm.
You said red face card. Like, there's only 3 face cards, right? You're saying
Red.
no cards. It
This
says
is just
face
like a
cards.
red card in general.
Oh,
I think that's what it means.
because it said face cards.
Oh, you're right. I thought it meant like just like red. You're right. Actually, yeah, I thought of it the wrong way. Okay, so my bad. Redo. So anybody that answered, you just thought of it as a red card, but that's my fault. So yeah, it's a face card as in like Jack, Queen, King. Okay. So remember that there's gonna be like 3 times 4.
How many cards are in a deck again?
There's 52 cards in a deck. This is a little confusing. So there's 52 cards in a deck, and then in each like suit, there's gonna be like ace, 2, 3, 4,
Uh,
5.
How many face cards for each symbol again?
3.
Yes,
And it King,
3.
Queen, Jack.
So then in total, there's gonna be like 12 like face cards in one deck, because there's 4 like suits. So there's 12 thingies total. And then obviously half of them are gonna be red, half of them are gonna be black. So here, let's just do it together.
Can I go get water?
Yeah, that's fine. So 6 are red out of 52 multiplied by, this is for card number 1. And then there's now 51 cards, and then 5 are red. So that's some number. I'm not really sure what it is. Yeah. Did that make sense? I think I might have confused you, but after you know that there's 6 red face cards, it should be simple. You minus 1 from the top, subtract 1 from the bottom as well. Yeah, okay. So now is where it gets tricky. So or versus and. These 2 words are super hard to differentiate in my opinion. So you're just gonna have to practice a little bit and see different examples to know this. So let's see. A jewelry drawer has 9 necklaces, 4 are silver, 2 are platinum, and the rest are gold. If you close your eyes and randomly grab a necklace, what is the probability that it is gold or platinum? So don't try to do any math, like complicated math here, I guess. Just think about it. What's the probability that it's gold or platinum? So Daniel, explain to us, why is it 5 nines?
Because 4 plus 2 is 6, and it says the rest are gold, so that means there's 3 gold. 2 plus 2 is 5. That will account for platinum and gold, and then just what's the probability of gold or platinum, which means 5 over 9.
Yep, that's perfect.
You really don't have to do any complicated equations.
Exactly. So gold is 3, platinum is 2 out of 9. Well, that's just 5 over 9. Notice that we added here, okay? This is what we're supposed to look like. No, you're good. We just did a simple problem. Okay, so I'm just gonna tell you this. If red stands for the desired outcome, this first one is and. And is like something happens and the other thing happens. Both things have to happen, which is like why it's the intersection. But for or, this or is different from like a speaking or. in math, or is if one of the two, like when there's two like options, if one of the two are true, it becomes like true. So or is like everything. You can think of it as like everything, and it's just where the two are like meeting. No, just normal or, like the word or. Okay, so this is something you might want to write down. So when a question asks for the probability of x and y, you multiply. So for and you multiply. For or you add. And then this part is kind of difficult to understand. So basically, in certain situations, you have to subtract this, like the multiplied part, because you are overcounting. So I don't want to get into it too much, but you should just know it like this, because like if I had, I don't know, like 3 blue pens and 7 shiny pens. Some of my pens are blue and shiny, okay? So I need to subtract those because I counted it twice by counting it in the blue pen category and the shiny pen. So you're just basically getting rid of the overcounting. But sometimes when the two events are mutually exclusive, which means that they don't really affect each other, then you just add. So think of it as normally adding unless there's overcounting. We'll see it in action. This is a little confusing.
Why would it?
but
Why would the question ask you for the probability of something or something though?
I don't know. They just do. Like, what's the probability that it's gonna rain on Tuesday or Thursday? Well, it might rain on Tuesday, plus it might rain on Thursday, like that. Okay, let's see, what does it say? You randomly draw a card from a standard deck and randomly choose the letter of the alphabet. What is the probability that the card is red or the letter is a vowel? So remember, this is just a card is red, so that's like half the cards are red. And how many vowels are there? Somebody shout it out. How many vowels are there? Come on, you should know this.
5.
Yeah, there's 5 vowels. Hopefully you know that. And there's 26 letters in the alphabet. So since it is or, remember that's or, so you add, okay? Oh, it moves. So since it's or, you do 1/2 plus, what is it, 26? 5 over 26, which is like 18 over 26, right? And then you have to subtract like the wait, there's no overlap, is there? Hold on. That the card is red or the letter is vowel. I think you just add because it's or. So just think like adding is or. I mean, or is adding. I don't know if we have time to do everything. Let's see. Yeah, let me see how many there are. What does this say? Story time. Okay, let's do this. I don't think we have time for everything. So, okay. Alrighty. This one is like more logic based. So knock knock, who's there? The government. Dr. X, we require services immediately. Open the door. So you toss 3 coins. If you get more heads than tails, you will decide to open the door. Otherwise, you will activate a trap door to send whoever it is at your door to fall into a giant pit. So what is the probability that you open the door? You don't really need to do any math for this, okay? So let me give you a clue. There's 3 coins, okay? There's an odd number of coins, and each coin is either heads or tails, okay? So let's see. I'll give you guys a second to think about it. Ooh.
I feel like you would get in more trouble with the government if you were to send them into a giant pit.
True. Okay, Shrey, explain to us why you think it's 1/2.
I thought because three could be like two
More
of them could be
heads.
heads and one of them could be tails, or like two of them could be tails and one of them could be heads, based on probability.
Mhm.
So that's why I think.
Okay, that's a pretty good explanation. Basically, there's an odd number of coins, so like half the time you're gonna get more heads and tails. The other half the time you're gonna get more tails and heads. So yeah. There's 1/2. And then you end up getting 3 heads, which is super rare. And then you see these men in matching uniforms. So you fall asleep on the journey to wherever you're going, and then you wake up and see what does that say? A dozen scientists standing over you. How many are in a dozen again? 10, 12?
Oh,
12.
Mm-hmm. So look, Dr. X is finally awake. So you pull out a deck of cards, and your favorite is the Ace of Spades. And you once had a dream that told you that anyone who picked the Ace of Spades or the Ace of Diamonds first try was trustworthy. So you shuffle the deck and tell one of the scientists to pick a card. So what is the probability that they are trustworthy? So basically, what is the probability that the scientist will pick the Ace of Spades or the Ace of Diamonds? Yep. There's 2 like desired thingies out of 52 or 126. Okay, so now you're like relaxed, there's trustworthy or whatever. Okay, so another government official walks in, tells you that they need 5 scientists for an extremely important top secret mission. So they will choose a scientist randomly since everyone here is qualified, and you get selected first to be on the mission. Since there's 12 scientists total, but if there's 8 scientists who like orcas, what is the probability that the other 4 scientists chosen all like orcas? So yeah, there's 12 total, 8 who like orcas. Well, basically, at first there's 8 out of 12 scientists that you can choose. Then one of them is like already chosen, right? So now you go 7 over 11, then 6 over 10, 5 over 9, subtracting 1 from the top and bottom each time. And now you multiply everything because it's like the first person likes orca, and the second person likes orcas, and the third likes orcas, and the fourth. So you have to multiply. I'm going kind of fast because I want to get to the fun activity. Okay, so just the story. You and the 4 orca living scientists set off. You get driven down to a pier where you see a submarine floating in the ocean. It was so small, and how could it possibly fit 5 people? So you begin to have a bad feeling in the pit of your stomach, but it's too late. You've already signed a contract with the government. To be continued, dun dun dun. So just keep this in mind for another class. Okay, now this is the fun activity I want to get to. So we're gonna play Jeopardy. Okay. Hold up, I already have one. Here. Okay, so let's vote, okay? Raise your hand if you, hold up. Raise your hand if you think we should do teams. And then can you do like other emoji thingies as your like thing instead of raising your hand, or no? Like a reaction, is that what it's called? Do you guys have that option?
We can.
You can or can't? Okay, can. So, okay. Actually, let's do this. If you want to do teams, clap. If you don't want to do teams, do the like confetti stuff.
What if I don't mind?
if you don't mind, don't do anything. Okay. So currently I see.
How do we play this?
Oh, it goes away. So keep like clicking it once it's gone. Okay. I think I saw a lot of people's, but now it's like gone. Okay. I see 1, clap. 2, 3. Okay. 2, oh, 4 claps and then 3 confetti thingies. That's like really close. One more person vote. Clap. Alrighty. Then that means we are doing teams, right? Yes. Okay. So let's see. Let's do 2 teams, okay? So let's see who's here. There's me, obviously, and then there's 16 of you, I think. So we're gonna put you guys into 2 groups. So how am I gonna do this efficiently? Okay. I'm not gonna randomly assign since whatever. Okay,
Can
so
we do you versus the class?
me versus the class.
Yeah.
I don't think that'll be like fair though. I'll probably beat you guys.
Yeah, who cares?
Are you confident enough you can beat me?
No, no. Well, like what we do in school is like if we get it right, we get the point. If we don't, you guys get the point.
Okay. Okay. So should we do me versus you guys or do like other like actual?
You versus us.
Okay, already. So me versus you, but everybody will go around picking the like square thingy. We'll take turns. So I'm gonna choose somebody random to pick our first square. Okay, I pick Shrey. Choose our first.
How would you choose it randomly? How do we know this isn't biased?
Well,
It probably
just trust me as your nice teacher.
Yeah, trust. Yeah.
Oh, you guys are the one choosing anyways. Okay, Shrey, choose one of the
You're
things.
the one choosing the choosers.
So it doesn't matter.
So
Choose 500.
Difficult dice 400. Okay. Do
wait, what is the images?
Well, you guys have to try it out.
No, but like, what type of question is it?
Oh, it just shows you like a picture, and then it's
we
like.
have to choose any of these numbers.
Okay, so you guys have like 1 minute to get it, and then you, the person who chose it, so Shrey, you have to be the person to give the final answer in case you guys don't agree. Okay, so the thing is, chance that after rolling 2 fair dice, the rolls sum to 7. This one's a little difficult, I think. So you guys can talk to each other, you know, you can unmute, which would be easier. Damien says 1-6. Daniel says 1-4. Who's right? You guys have until 7:48. So and then Shrey will be the final person to choose. What?
I accidentally copy pasted something from another assignment. This is so weird. Please don't read any of that. That was an accident.
Okay.
Oh God.
Alrighty, Mr. Shrey, tell us, what is the final answer?
Recording.
Unmute and tell us.
I'm gonna say 1/6.
Yay!
Okay, big reveal. Wait,
It's 1/6.
you're right. Good job. So you guys are gonna be team. What's your team name? Choose one really fast.
Team 2.
Your team name is Team 2?
Yes.
Team name is Team 2. Okay. Team 2
Wait.
without a space, I guess.
Oh.
Alrighty. So team 2, you get 1 point. Now it is me. So let's make this go away. I have like no space on my screen. Oh my goodness. Okay. Escape. How do I get
What?
this? Oh, okay. I'm gonna choose images for 500. Let's see. The probability that you spin this wheel twice and it lands on green and then blue. So it says and, right? So now I know it's an and question.
It's 3.
So you first one to do green. So there's 3 out of 5 and 1 out of 5. So 3 out of 25. People are helping me in the chat, aka Daniel. Let's see. Were you right though? My answer is 3 out of 25. Oh my goodness, I'm beating you guys. I'm in the lead.
You know
Okay.
these answers.
Why
Um,
was that? Why was that 500 points? It was so easy.
Exactly.
Okay,
And or 500.
Colin, choose it.
Oh, okay. I don't like cards, so
And or 500.
Let Colin choose.
I don't like and or either.
Okay, difficult dice
Yeah,
500.
yeah, difficult dice 500 because I like dice.
Okay, what is the probability of rolling 2 dice and getting an odd sum? You guys are picking hard questions, in my opinion, but you got it last time, so let's see if you can get it. Okay, somebody says 1/2 in the chat. Multiple people say 1/2 in the chat. Okay. Alrighty. Colin, what do you think? Tell us the answer.
Okay, I'm going with the chat 1/2.
Okay, big reveal. Big reveal. Hello, why isn't it revealing? Oh, okay. Yeah, you guys are right. Okay. So now you guys are at 900. I'm gonna take the difficult dice 300 since you guys seem to like it. Okay, Frankenstein rigged a die to have 1/2 chance of rolling a 6 and equal chances of rolling all the other numbers. Find the chance that he gets a 6, 1, or 2 when he rolls his die once. Ooh, this is confusing. Okay, let's see. So this, or this. Okay, so I think it's telling me to add, right? So first, to get a 6, there's half the chance. Or since the other half is distributed to the other 5 numbers, that's 1/10 per each one. Okay, so that's gonna be like 1/2 plus 2/10, which is 1/5. Well, that's the same thing as 5/10 plus 10/2. I mean 2/10, which is 7/10. Okay, that's gonna be my answer. Let's see if that's right though. I actually don't know. Okay, yeah, good job, me. So I'm at 800. You guys are at 900. Okay, next I'm gonna pick I'm gonna choose Damien. Choose one of the thingies.
Choose something 500.
All right, Damien.
Yes, choose. Unmute.
Review
Unmasked.
500.
Review 500. Okay. How many squares are in the picture? Ooh. Count carefully.
Interesting.
$23 says Shay. Okay. It's 30.
Okay, it's 30. I'm gonna annotate whether you like it or not. So there's a big square. There's 4 medium squares, Well, actually, there's also medium square in the circle. So there's 5 medium squares. There's 1 big square. There's 16 little squares, and there's 8 more really tiny squares. So that's 1 big square. So that's 1 plus 5. So 5 medium squares plus 16 pretty small squares plus 8 really tiny squares, which is 30.
Ooh. The highest answer I see right now is Daniel, which says 40. The lowest answer I see is Venkata, which says 18, I think that's the lowest. And then Colin is sure it is 30. So now, who
I
was
think it's 34, actually.
Damien, you should call.
Oh wait, no, it's 32. It's my math, but I forgot the medium squares. I forgot this square. So it's 32.
Okay.
100% 32, 100% 32. Damien said 32.
Damien, unmute and tell.
32.
Big reveal. Okay.
Yeah, it's 32. I'm confident.
I'm confident it's wrong.
What?
Wah, wah, wah. Who said 40 in the chat? I think
Me.
who's-
Daniel.
Daniel.
You guys forgot that there's middle squares literally in the middle. There's technically like 9 of them.
What? I draw it.
There's
draw it.
literally 9 2x2 squares because there's like, like the top row, and then you have to count. There's three rows of,
Oh my god.
Like 1, 2, 3, like that.
Oh my god.
5, 6.
I've been bamboozled.
9.
This is so sad.
Good job, Daniel. It's okay. You should have advocated for your answer a little more.
You should have advertised your answer.
Damien said his
You
decision
should have
was
made
final.
your point. You
Hello?
just stood there, typed 40 in the chat, and then just left.
Wah, wah, wah. Okay, so let's see. I'm gonna choose
Do a 100.
do a 100. All right.
Yeah, I want it to be even. And then let's see.
Okay, I'll do cards 100. Probability of pulling out a red card from a standard. Oh, that's easy. 1/2. Yep. Okay. Alrighty. For the person that's gonna pick the tiebreaker, I'm gonna choose somebody. I'm gonna choose Jack G.
Ugh.
Oh my god, it's okay, Venkata, or whoever said that. Okay, I'm gonna do a 500. Should I do and or cards?
Cards.
Okay, deceptive deck of cards, 500.
Alrighty. The probability of that that you draw a card, don't replace it, and draw a second card with the same value. So the same value would be like a 6 and then a 6 again, something like that. Let's see, let me think about this too. Okay. I think this one was tricky.
Well, I mean, you wouldn't need a probability for the first draw because it doesn't have to be a specific draw. It doesn't have to be a specific number on the first draw. It's just the second number. So definitely not Shrey. Shrey. It's definitely wait, no, I don't know. I don't know.
I feel a bit like Trey is right, a bit.
Well, I mean, I don't know if the first draw would matter because the first draw doesn't need to be a specific number. It just has to be the second draw.
Okay. Well, Shrey seems adamant that you two have to care.
Yeah, I think it's 3/51.
It says like and, so you would have to times both values. So like the first value would be 452.
Yeah, but
times
why is the first value
51.
4/52? It's not asking for a
There's
specific
4 of
value.
them. There's 4
Yeah,
of
but it's not
the-
asking for a specific number for the first value.
Okay.
It's not asking for a number.
Now, everybody, let's let Japji say the final answer. Okay, what do you think it is?
Japji, stop sleeping. Wake up.
Oh my God. You know what? I'm going to change that. Well, anyway, people, what should I do? Just give me, shout out an answer real quick.
3/51, I guess. I don't know.
Okay, 3/51.
Okay, big reveal. Who was right? Dun,
It's
dun.
wrong, obviously.
3/51, that's the same thing as.
Why
Yeah,
didn't you say it was wrong before
Vincata,
the
you
answer?
liar.
No, that was Shrey that was arguing with you, I think.
3/51 is
The 1/7.
0.05882352941.
Vincata, stop using a calculator.
They're the same thing. At least I'm 99% sure they are. So, okay, well, good job. You guys kind of far ahead. We have time for one more. Let's see. In order for me to catch up, I have to get the 500 one right? So I guess I just have to do this. There are 6 boys and 5 girls in a class. They are randomly picked to present one at a time. Find the probability that the first is a girl, the second is a girl, and the third is a boy. Whew, okay, so, well, it says and, so I'm going to multiply both times. Multiply and multiply. So now I have 3 fractions. First, 5 girls out of the 11. Then if you already went, then you're not going to go again. So now there's 10 people left, and then 4 girls only. Now there's 9 people left, but there's still going to be 6 boys. So I think this is right. So let me do the math. Cancel 2, cancel 2, 2/3 instead. Okay, so this is kind of messy, but 4/33. That's my final answer. I'm gonna make this my final answer, but do you guys see what I'm doing? Does that make sense or no? Do you agree with me or no? Basically what I'm trying to.
I don't really care.
Okay, let's see. Big reveal. Except I can't reveal because there's drawings. Okay. Ahaha, I'm right. Of course.
I disagree with you. I protest.
Okay. If you guys want, I'm gonna give you the chance to do one more question, but this time I'm only gonna give you 1 minute for sure.
Guys, let's do images for 100 because that's all we need to beat
So,
beat her.
I'm gonna choose Venkata to choose it. And
Vincata, just do 100 because this is the last question we're doing. We're already over time, so just do one for 100. On like, I don't know, difficult dice or something, or images.
Choose.
Images are difficult dice because they seem pretty easy.
Is he even there?
Oh, sorry. Let's do images for 400.
No, do it for
No.
100. This is the
Okay.
last one.
Bet.
This is the
Vincata,
last
do it for the.
one.
No, Vincata, look what you did.
Okay, you guys have until 8:04 since it's like already halfway through 8:02. Okay, as soon as it turns 8:04, I'm asking Venkata for the answer already.
Okay, give me answers. I don't want to do this.
Why
Wait
do you
a second, all of them-
400 then?
All of them have white on. Have white pupils and black irises or whatever.
Don't.
Oh my
That's fair.
god,
Don't.
we cheated the system. It's 100%. Well, I mean, it's hard.
technically,
It's hard
I'll
to
go with
say
that.
for this one because you could say anything is. You couldn't say anything is white. Like you could prove a point.
Somebody stop wasting your time and actually giving the answer because we don't have enough time right now and I don't want to do it.
I'm making a point by not like trying at all. So I haven't tried for any of these.
It's 136 because like 2 9s times 1/8 is 136.
I'll just believe in Shrey. He's not that smart, but we'll go with his answer.
Oh my God, you see that
So
for
mean.
everyone.
That is so brutal.
Which one of them? Which 2 animals are black and white?
The cow and the panda, obviously.
Okay, so
Literally
those
all
are
of
the.
them, though.
What about the
If
skunk?
you think about it.
There's no
Claire, there
skunk.
isn't
There
a
is
skunk.
no skunk.
What?
Let's go with
My sister said, "What about the skunk?"
136.
Are you sure?
It's 1 over 36.
136.
It's 136.
Okay.
Yeah, I'm gonna do it because Trey said so, and I'll let him use his answer, and he'll give me his homework. So okay.
Okay, it's
Alright,
8
just
o'clock.
hurry
Let's
up.
take reveal. Ready?
Reveal the grand reveal.
Oh,
Yay.
such a genius. Good job. You
I
guys,
am slightly smart, yay.
you guys won. How's
Okay, we're done.
Yep, you guys can go. Goodbye. Come back next time though.
Okay, I'll try.
Okay. Bye guys.